For most of history, the inner solar system has kept its secrets, until now. On September 25th, 2025, the third interstellar visitor ever witnessed by humanity, 3I/Atlas, was struck head-on by a massive coronal mass ejection from the sun, just as two powerful earthquakes shook Venezuela and twin novas ignited in the night sky. Scientists are scrambling to understand if this extraordinary chain reaction is pure coincidence or a warning sign written across both Earth and the cosmos. This is breaking. Something just hit 3I/Atlas, two big earthquakes rupture. But what does this convergence really mean for us? And what will happen as 3I/Atlas rushes toward its fateful encounter with our sun later this year? It's difficult to grasp just how empty the universe truly is. Our solar system, with its familiar planets and looping comets, occupies a tiny oasis in a desert that stretches for trillions of kilometers in every direction. Beyond the orbit of Neptune, at the edge of the heliosphere, the twin Voyager probes drift in silence. Launched in the late 1970s, these spacecraft are the only human-made objects ever to escape the sun's influence and enter true interstellar space. In all the decades since, nothing else from our world has crossed that invisible border. And in the opposite direction, only two objects from the galaxy beyond have ever been seen passing through our neighborhood. 1I/Oumuamua in 2017 and 2I/Borisov in 2019. Each arrival was a statistical marvel, an interstellar visitor threading the vastness, detected for just a fleeting moment before vanishing back into darkness. For context, billions of comets and asteroids orbit the sun, yet only these two have been confirmed as outsiders. That's why the discovery of a third, 3I/Atlas, has sent astronomers into a frenzy. The odds of witnessing even one such crossing in a human lifetime are vanishingly small. To see three within a single decade is almost beyond belief. For scientists, every interstellar object is a message in a bottle from another star system, carrying secrets of distant chemistry and cosmic history. The arrival of 3I/Atlas is not just a rare event, it's a reminder of how isolated and how briefly connected our solar system is to the rest of the galaxy. On the night of July 1st, 2025, the Atlas Network's telescope at Rio Hurtado, Chile, picked up a moving speck against the star field, an object drifting in from the outer reaches, well beyond Jupiter's orbit. ATLAS, short for Asteroid Terrestrial Impact Last Alert System, is designed for relentless sky patrol. Its 4 automated telescopes, spread across Chile, South Africa, and Hawaii, scan the heavens every clear night, capturing hundreds of images and flagging anything that shifts position from frame to frame. This particular detection stood out. At a distance of 4.5 astronomical units from the Sun, roughly the same as Jupiter's orbit, the newcomer's path didn't match any known object. Early data showed it was moving too fast and on too steep a trajectory to be bound to our solar system. Astronomers at the Minor Planet Center ran orbital solutions using every available sighting, including pre-discovery images from June. The calculations revealed a hyperbolic orbit, the mathematical signature of an interstellar traveler. Spectroscopic follow-up began almost immediately. Observatories from Chile to Hawaii measured its faint glow, searching for chemical fingerprints. The results were striking. The object was rich in carbon dioxide, far more so than typical solar system comets, along with traces of water vapor, carbon monoxide, and even atomic nickel. This unusual chemistry, combined with its unbound trajectory, confirmed its status as the third interstellar object ever observed. By mid-July, the astronomical community had a new focus, 3I/Atlas, a messenger from the galaxy beyond. On September 25, 2025, the universe seemed to set its own agenda. At 10:30 UTC, solar monitors registered a powerful coronal mass ejection erupting from the sun's surface. Within 23 minutes, that wave of charged particles was confirmed to have intersected the path of 3I/Atlas, the newly discovered interstellar comet now racing between Mars and Jupiter. Less than an hour later, astronomers around the globe caught the first flashes of not one, but two nova explosions, V7994 Sagittarii and V1935 Centauri, each flaring up in separate corners of the Milky Way. Both events were reported within hours of each other, an astronomical rarity. Just as news of these cosmic fireworks began to ripple through observatory networks, the ground in northern Venezuela convulsed. Seismographs recorded a magnitude 6.2 earthquake, followed almost immediately by a 6.3, sending people flooding into the streets of Sucre and Monagas states. Cell networks jammed as emergency alerts echoed across the region. For a few hours, the world's attention was split between the drama unfolding in the sky and the chaos on the ground. Social media erupted with speculation. Hashtags like #CosmicWarning and #AtlasImpact trended as infographics mapped the novae, the comet's solar encounter, and the earthquake epicenters in real time. Scientists and amateurs alike scrambled to confirm details, their feeds colliding with memes, theories, and anxious commentary. Nothing in the official record linked these events, but the sheer simultaneity forced even the most skeptical observers to pause. For a brief moment, the world watched as cosmic and terrestrial forces seemed to move in lockstep, daring anyone to call it mere coincidence. Within hours of the news breaking, the world's scientific voices stepped into the fray. Avi Loeb, chair of Harvard's astronomy department and a familiar figure in debates about interstellar phenomena, weighed in with a measured statement. This interstellar visitor's finely tuned path past Mars, Venus, and Jupiter, the rare direct hit by a CME, and its composition challenge all our expectations. Yet Loeb cautioned against drawing cosmic connections to the Venezuelan earthquakes or the twin novae. He argued that while the timing was extraordinary, the laws of physics offer no mechanism linking a solar eruption, distant stellar explosions, and seismic rupture on Earth. The United States Geological Survey moved quickly to address the speculation. Their official bulletin read, "There is no scientifically credible evidence for a link between solar ejections or astronomical novae and terrestrial seismic activity." Geophysicists pointed to decades of research on solar activity and earthquake timing, noting that even the most energetic coronal mass ejections fail to deliver the forces required to trigger tectonic movement. The mathematics of coincidence, they reminded reporters, can produce dramatic overlaps purely by chance. Still, the internet had its own logic. On talk radio, the narrative shifted from skepticism to outright alarm. Hashtags like #CosmicWarning and #AtlasImpact flooded social feeds. Amateur theorists posted diagrams linking solar wind models, nova outbursts, and seismic charts. Forum moderators pinned debunking threads, while YouTube personalities speculated about cosmic warnings and hidden patterns. In this maelstrom, the boundary between scientific caution and speculative hype blurred, leaving the public to navigate a landscape of expert statements, viral memes, and unanswered questions. Carl Jung coined the term synchronicity to describe moments when unrelated events seem to converge in ways that feel deeply significant. For Jung, these encounters weren't about causality, but about a kind of meaningful coincidence and a causal connecting principle that challenges our sense of order. Statisticians, on the other hand, approach such clusters with a different lens. David J. Hand's improbability principle suggests that given enough opportunities, even the rarest alignments become almost inevitable. In a world of billions of moving parts, improbable patterns are bound to surface. Yet when the universe delivers a sequence as unlikely as a comet struck by a solar storm, twin novae, and twin earthquakes, the line between chance and meaning blurs. Are we simply pattern-seeking minds adrift in randomness? Or is there something more at work when the cosmos and Earth seem to move in concert? With the world's attention fixed on 3RI/Atlas, astronomers are already mapping out the next critical milestones. On October 3rd, the comet will pass just 0.19 astronomical units from Mars, about 28 million kilometers. This close approach offers a rare opportunity for orbiters like Mars Express and the Trace Gas Orbiter to gather detailed measurements. Then, on October 29th, 3I/Atlas reaches perihelion, its closest point to the Sun, at 1.36 astronomical units. For most of October and early November, the comet will slip behind the Sun from Earth's perspective, hidden in the glare. By November 3rd, it will swing past Venus at a distance of 0.65 astronomical units, re-emerging into the dawn sky and fading as it speeds outward. Hundreds of telescopes worldwide are scheduled to track every phase, hoping to catch any surprises this interstellar traveler might reveal on its way through our solar system. On September 25th, 2025, three rare events unfolded within hours. A coronal mass ejection from the Sun struck interstellar comet 3I/Atlas. Two nova explosions appeared in the night sky, and Venezuela experienced magnitude 6.2 and 6.3 earthquakes. The Atlas survey's detection of 3I/Atlas just months earlier marked only the third confirmed interstellar object ever observed, with its hyperbolic path and carbon dioxide-rich composition confirmed by multiple observatories, while official reports from the USGS and astronomical organizations find no causal link between these cosmic and seismic events. Their coincidence remains statistically remarkable. Some questions persist. Could unknown processes connect distant phenomena? Or are we witnessing the play of chance on a cosmic scale? As 3I/Atlas approaches perihelion on October 29th and nears Venus in early November, global observation campaigns continue. The facts remain, our understanding is expanding, but some mysteries endure. For now, the records show an unprecedented convergence, one that scientists will study for years to come.